those of you who joined today as their first session, I would like to welcome all of you and thank you so much for your time and thank you so much for joining us. My name is Pooja Karmakar. I am currently a computer engineering third year student from a University of Bahrain. And today, me and my friend Leila, would you like to introduce yourself?
Hi everyone, my name is Leila and I'm an information system stack developer and I'm participating in Google Developer Student Clubs as a co-member with my friend Bojan and Jafar and the others, Nabil, Sabine, thank you.
Yeah, so if you are interested in being one of the core team member, you can just contact Abdurrahman and he would guide you through. So me and Leila, we would be co-hosting or co-presenting the session today. And the topic we chose is how to approach technical interviews. So this is one of the, hot cake. It is one of the topic that everyone wants to know the answer of, but we kind of, if you are like me, who does a lot of research and searching up stuffs in internet forever. So if you're like me, you will be searching up in the Google and you are tired of the answers you get. So me and my team, me and Leila, we kind of curated this slide to make you people understand. And if you're someone who still haven't done any technical interview, glad you're here. I'm happy that you're here with us because this is what the presentation really looks into. We will be looking into from the scratch, where to start, how to start, what to do, what not to do. And at the end of the day, we are all here to learn. So I think this will be a good session for the beginners and also for the intermediate ones. And even if you are someone who are already done technical interview, but you face some challenges, I hope me and Leila, we cover it up in the slides. So let's get started. Okay, the contents that we will be looking into in today's slideshow would be how to prepare, what do you need to know when you go for a technical interview, and if you are presented a problem or if you have presented as maybe a code, how do you dissect it and how to present it to your interviewer in a manner that he will be impressed by you. Okay, we will be looking into that where we will be covering out a systematic manner of doing it. So I know many of you know the ways of doing it, but not exactly the systematic one. So me and Leila, we will be covering up how to do it systematically so that you don't lose any point, you don't miss out any of the important core details from the problem. And then what to expect from an interview and how to optimize and solve a problem given to you and what are the basic techniques to solve it and how to handle the question. So if the question is hard, you don't know how to answer it, but you still want to show your interviewer a positive side of you that you are trying. So we will be dissecting that also. And at the end of the day, we all know that a technical interview basically shines if you have a good code. So we will also look into what good codes look like. What is a good code in the end of the day? So many candidates are intimidated by how difficult the questions are, but always there are some logical approach. So this is what we will be looking into, the logical approach of the things. The first topic is how to prepare. When you go or when you walk into a technical interview, before a day before your technical interview, how do you prepare it? What are the steps that you have to consider before going directly to the code or before directly joining your technical session? So these are a few of the steps that will help you us. So let's take step by step. So the first step is try to solve the problem on your own. Okay, guys, remember, try to solve your problem on your own. So whenever a problem is shown to any candidate, suppose me, when I was in my university time, whenever I used to see a question and the professor used to say, okay, this is important, I always used to like memorize it, and until it is there in my brain, I keep on memorizing it. But guys, that is not how it works. Okay, that is not how it works. At the end of the day, I sit on the exam and I forget 80% of the stuff by memorizing it. So if you are a good memorizer, I'm saying good for you, but that's not the logical approach at the end of the day. So many candidates just read through the problems and solutions. That's like they're trying to learn calculus by reading a problem and its answer. You need to practice solving problems. Memorizing solutions won't help you much. And you should also consider solving a problem. You should think about the space and time efficiency of the particular code when you're trying to solve the problem. And the next thing is writing the code on paper. Yes, this is something which we don't necessarily do in our day-to-day life. But why do you think we should write a code on a paper? Yeah, I understand that when you write a code on your laptop or on your IoT devices, you get the luxury of syntax error, highlighting, code completion, quick debugging. These are all the things that are the luxuries that we get. But at the end of the day, when you are in an interview, I understand that writing a code is a slow process. But at the end of the day, when you are in front of your interviewer, you must know what each of these code lines stand for and why exactly are you using this particular code. So until and unless you try and do it on a paper by your own hand, it will not be as efficient as you do on your laptop, suppose on your laptop. And the next thing is test your code on paper. Again, when you write a code on your paper, make sure to test it at the same time. Make sure that you test the general base and error cases of any particular code or algorithm. Because, anyways, in the interview, you have to do it. You have to test your code on a white, maybe a white background or something, maybe a shared document. You will be the one testing it and you will be the one writing it. So why not practice it beforehand? So the more the practice you do by yourself on a paper, testing it yourself, the more efficient and more better you get. Again, now what we usually do after we wrote the code, we test it. The next part is writing the exact code in the computer. Yes, now this might be controversial. Yeah, writing the exact code on the computer means you will see that you created a bunch of error. There are a lot of syntax errors. There are errors that maybe you missed a colon, maybe you missed, a lot of syntax error in general. Maybe there is some error with the bug. There is a bug that you showed up. So make sure that you understand what each error, why did this error exactly happen, and also list it down. Maybe you take a piece of paper in front of you, list down what error did you do, so that during the interview you know, okay, this was the error that I did in the first place. I will be 100% more careful to not do this on my interview. Yeah, so I hope this is clear. Let's go to the next part. I know these things are very basic, but these are some of the logical way of doing it. Maybe we might do it in, there might be some modification of your own. Maybe you write the code on paper, but you test it on maybe you test it on your computer after the step. But these are some of the logical approaches you can you can try it in general, and I hope it helps for you. Let's go to the next one. Yeah, the main thing, the main doom. Whenever we think of preparing a technical interview, we are always confused, or maybe we are overwhelmed with a lot of data structures, a lot of algorithms. Maybe if you're someone who completed their 4-year major and now you're about to give your first technical interview, you will be lost because in the 4-year course, you might take a lot of algorithm concepts, a lot of data structure concepts, so you might be lost. But how to start? If you're someone who want to start, how do you start? Where is the starting point? So, okay. So whenever you go to an interview, you're expected to know the basics, and it's a bonus point. It's a bonus point if you know more than the basics. So let's see. Yes. This is a table that shows the data structure, the algorithms, along the concepts. So the data structures are linked lists, trees, graphs, stacks, queues, hash tables, array lists. Algorithms are binary search, merge sort, quick sort, etc. Concepts could be a bit of manipulation, something with the memory and the stack, a recursive method maybe, a big O time and space. Okay, if anyone who is joined second time with us, me and Leila, we have previously talked about big O notation. That is also a huge, big concept in general interviews. All the algorithms you write, you kind of have to show the efficiency of the algorithm. So big O notation will be helping you out. And if you're someone who just joined us today for the first time, don't worry, we will be in the coming sessions, me and Leila, we will be covering up everything about the data structure. We will be talking about hash tables, trees, linked lists. So feel free to join us in the coming session. Yes, it will help you. What does this table do? It will help you to learn how the internal of the data structure works, which is very important for the interview. Yes, you know the basic of the hash table, but you don't know where the data are stored, or you don't know how it works. Then you're done. Then you're done for the interview. You at least have to know the internal part, or why you're using particular algorithm, why you're using particular data structure. At least you should know the basic. And at the end of the day, in the coming slides, you will see that we talked a lot about hash table. And actually, hash table is extremely important topic and a vast topic in itself. So we will be, if you're new and if you don't know anything about hash table, don't worry. Me and Leila will be covering it up in the coming session. But just for now, remember that hash tables are one of the most important topic at the moment in technical interviews. Even if you're not very comfortable with each of the data structures and algorithm listed, but you have to practice implementing them from the start. Just start from the scratch and maybe start linked list at one stage, and then stacks, and then continue through it. Just start from the scratch and you will be good to go. There are some more things that you kind of need to know is a power of two table. So a power of two table has the exact value of x, the data or the location. Why do we usually use? Okay, many people might ask you, do I have to memorize this table? No, it's not strictly required. But at the end of the day, it's useful if you memorize the power of the table. But at least you should be comfortable deriving it. Maybe someone has said you, what is the power of 2 to the raise of 16? Power of 2 to the raise of 20. At least you need to know what is the space and all, memory size, memory location. So it's useful for many questions that involves scalability or the sort of memory limitation. So you need to at least kind of know the basics out of it. So now you are, suppose you are in an interview. You started the interview, you did the introduction, hello, how are you, blah, blah, blah. You finished that. Now your interviewer has given you, suppose, say, an example, or you are just about to start the example. There is also a very nice flow chart, step-by-step way of doing stuff, rather than taking everything in your brain and overwhelming yourself. So that's what we will look into the coming slides. Yes. So the first process is listening. I know this is very basic, but believe me, when we think about listening, we are not everyone, but most of us are not a great listener when it comes to technical interviews. That's why we emphasis on the point of listening. Then it comes to example. We will write an example. Brute force. Here, brute force means exactly the first idea that comes into your mind whenever you see a problem. The first, what do you say? Maybe when you draw a picture, the first line or the first stroke which you put would be a brute force. So in case of coding, maybe the first line of code or the first set of code will be your brute force, or the very beginning of your idea. Then we will optimize it, look into it. Is it okay? Is it not okay? Do I have to change something? Do I have to add something? And then we will walk through it. We will again reassemble our codes, reanalyze it, see if there is any missing points. Then we will implement it. And last but not the least, the most important part, we have to test the code. We have to test the code. So this is a way to solve a problem. Listen carefully. What do I mean by listen carefully in case of generally speaking? Rather than generally speaking, there is some technical terms which have to. Okay, we have to pay very close attention to any information in the problem description. We should also probably note down the optimal algorithm. We should also try to write down the useful information, maybe say in a piece of sheet or in a whiteboard. So you do want to ask questions about anything you're unsure about. When you're doing an interview, make sure to ask questions. Don't feel like, okay, the person in front of you will be judging. That is not the case. You should be comfortable enough to ask questions to your interviewers that you're unsure about, because I'm saying you beforehand, if you're not sure enough about maybe a topic, you in the interview, you will be the one who will be facing issues in the coming process. So make sure that you're sure about the question. Okay, also mentally record if there is any unique information. Maybe you have given, suppose you are given an array, we will look into one of examples, but make sure that you mentally record if there is any unique information. Okay, why am I putting emphasis on listen carefully? Because we all have a habit that we miss out the key details of any problem, and we forgot that after 10 minutes on the program, and then we are lost, and then we don't know what to start, where to start, shall we start it again? I suggest that's why we ask the question again and again. Be sure, mentally record it, everything in your brain, you know, okay, what is happening. So let's look into one of the examples. Yeah, this could be a very small example. So the example is you are given two arrays that are sorted, and then find anything, or maybe say find an x value, find a y value. So if you notice, this is a very small example. And here they have mentioned about sorted. So maybe what do you think could be the unique information in this whole example? So the unique information could be the data is sorted here. The data here is sorted. So remember, the optimal algorithm for the sorted situation will be different from that of unsorted one. Obviously, maybe if you miss the sorted part, maybe you forget about it, you will be having two different codes. There will be one something that is for the sorted one and something for unsorted. So don't miss out the details. Try to remember it as much as possible. The next step is, yes, draw an example. Why drawing an example is so important? An example can drastically improve your ability to solve an interview question. So what we usually do in general, we always listen something and we try to solve question in our head. Yes, we all do it, admit it. Whenever we see a question, we try to solve things in our head, and that's not a good approach. That's never a good approach. So we should try to maybe take the bunch of information, squeeze it, and try to create a good and a specific example. Try to make the best example as much as you can. So what do I mean by a best example? So a best example could be specific. It should be sufficiently large. Okay, what do I mean by sufficiently large? I mean there should be at least all of the conditions, maybe if statement, else statement, check with base cases, check with say while loops. So make sure you have a lot of the example is large enough, and also make sure there is no special cases such as maybe an exception or there is no bug or no error, and just try to fix it up. Okay, let me go to the next one. Yeah, state a brute force. Okay, some candidates don't state the brute force because they think it's both obvious and terrible. What I mean by brute force is the line of code that we do at the very beginning. So many of us shy out. Is that a word? I don't know. But many of us shy out, and we feel like, okay, if I put my guards down, suppose if I write this, my interviewer will know that I don't know anything about it, or he might judge me on it. He might doubt that I'm not the applicable person. But I'm telling you, that's the wrong approach, because it is expected to make mistake. So feel free to state your codes. Feel free, no matter how obvious and how terrible or how slow your algorithm is. Feel free to put it down. because putting whenever you put it down, you can kind of wrap it around your head. You know, okay, this is the thing I'm working out. Maybe you find out a different side of the example, or maybe you find out a different aspect of it. So once you have the example done, state the brute force. It's okay and accepted. I repeat, it's okay and expected that your initial algorithm won't be very optimal. Yes, it won't be very efficient. It won't be very fast. And make sure to explain the space and time complexity, and then you dive into improvements. This is not where we stop. We have to improve our code. We have to improve our algorithms. So the next step of the flowchart is optimization. Okay, what do I mean by optimization? BUD optimization. Okay, what does BUD stands for? Might be your first question. BUD stands for B stands for bottlenecks. U stands for unnecessary work. D stands for duplicated work. So after I listened, I wrote the example, I wrote the brute force. Now it comes to optimizing the code or optimizing the algorithm. Now many of you might ask, what is bottleneck? We will be focusing on it in the coming slides, but I will just say you in one word is the line of code that slows down your runtime. Okay, the line of code that slows down your runtime of the overall program in general, maybe a chain of codes, or maybe unnecessary information or repetition of the same thing. Yeah, so we will come look into it in the coming slides. So what and how do you do the optimization of your code or your algorithm? So look for any unused information. Okay, look for anything that you missed. Maybe you forgot about the sorting thing, maybe you forgot about the merging thing. Look for it. Use a fresh example. So many times, a big mistake that most of the candidate does is that we repeatedly use the same example again and again, and we make the same problem again and again. So just try to freshen it up, use a new example, look through it, and also solve it incorrectly, and then think about why the algorithm fails and how can you fix this issue. So that means, like, suppose you use the same example and you found there is an error. Now now think now think how efficient is your example. Okay, look for some other example. Check what is the problem with your algorithm, why is it running slow, or why is there issue, is there any bugs? If there is any bugs, try to figure it out, and do it in a manner um, that will help you out in general. Sometimes just seeing a different example will unclog your mind or help you see a pattern in the problem. Okay, make a time versus space trade off. What do I mean? That sometimes storing extra state about the problem can help you optimize the runtime. So just make sure that you know what are the spaces, what is the space, what is the total space your algorithm or your code is taking up. Is it making the whole overall code slow? Is it taking up much of the space? So make sure that you know what your code exactly is doing. At least, not, if not exactly, but at least have a optimal view around it. Think of, as I said previously, that think of the time and space complexity, break it down through it, rephrase it, revise it. And then again, I'm emphasizing again that we have to check if the hash tables are there, if you use the hash tables, because hash tables are very useful in case of optimizing. So that's also a point. Then the last thing is think about the best conceivable runtime. Again, I'm saying that when we write a code, we see everything, but we have to know that is our code the best case, the worst case, or the expected case. We have to make sure that we are closer to the best case scenarios. Best case scenarios, I mean, like your time and your runtime of the code in general is fast enough. That's in general. Yeah, let me go to how long your code is running and everything in general. Let me go to the next slide. The next topic is walking through. What do I mean by walking through? Okay, Make sure you understand each detail before you start coding. Again, many of the candidates do the mistake of listening the problem and starting the code. You should be aware that the first step after seeing a problem is not starting the code. You cannot just start a code and then go on building the code, and at the end of the, say, suppose before you submit, you realize, oh my god, I missed the sorting part. Oh my god, I missed this crucial information. So never start after hearing the question. Never start just by writing the code. Make sure you do the examples and all the flowcharts. Okay, there are some ways. Okay, I'll see. Take a moment to solidify your understanding of the algorithm. Yes, take a moment, revise it, see what all errors is there, how to fix those errors and everything. If you're someone who is about to start, what should you do? If you ask me a question, then what do you think should I do before starting the code? You should always start a pseudocode. Pseudocode is something which we is like a small code in case where you use strings to define your overall coding system. The next thing is implementing, how to implement it. Now that you have like an optimal algorithm and you know exactly what you're going to write, we will go ahead and implement it. If you see something that you can refactor, if you see there is an issue, if you see there is maybe your code is not running properly, or maybe you went into an infinite loop in a code, so uh, a proper code and you have to kind of polish it up. So in case of implementing is just about writing a beautiful code. Here, what do we mean by writing beautiful code? It means you have to have a modularized code. You should check the error. You should see the classes and the structures, and you should also use good variable names that is understood by everyone in general. So if you see something you can refactor later on, then explain this to your interviewer and decide whether or not it's worth the time to do so. Usually it is, but not always. If you find that there is an error at the very end, maybe you don't have time for it. But if you put on 2 or 3 lines of code and it will run through it, explain this issue. Do explain this issue to your interviewer and explain what do you think is the problem and how can you solve it. If you get confused, which is very common, go back to your example and walk through it again. Very simple words. Okay, the last but the most important step is testing it. Testing it out. What do I mean by testing it out? So, after you finish the code, what will be the steps? How do you test it? So, the first test could be a conceptual test, which means that just reading and analyzing what each line of the code does. Think about it like you're explaining the lines of code for a code reviewer. Doing the same code, what do you think you should add on? What are the things that you repeated again and again, and you will just omit it out? So it's basically like talking to your friend and explaining your code in general. The second will be unusual or non-standard code, maybe something that is not a general case, or that is not a built-in function. You saw there is some issue with it and you just remove it. Or maybe try to explain your interviewer about it, or use more optimal code. Okay, the next one will be hotspots, like arithmetic and null codes. So hotspots, okay, if you are going into a technical interview, you're expected to know the basics, as I said before. So whenever someone has presented you a line of code, you will obviously understand, okay, this looks fishy. Okay, this line looks little bit fishy. Did I miss something? Did I miss an error? Okay, why is this code so lengthy? Did I miss something? Did I duplicate the same thing? Usually what I do, I usually copy and I use copy paste a lot, whereas I copy a same thing double the time. So that makes my whole code look lengthy, whereas I did a small mistake. So make sure that you're looking into it in a proper way, and also use test cases that are faster and that are effective. And also make sure that you use, if you're using special cases, and you find out there is a bug, try to fix it. But again, I'm saying, what we usually do, suppose I wrote a code, I saw, okay, there is an error, okay, this, there is a bug that's appearing. I will a general person will directly go and try to fix it at the same time. Don't do that mistake. I'm repeating, don't do that mistake. Just seeing once and you just directly go rub the whole thing and start doing the whole thing again, or the whole chunk of code again. Don't do that. Think again, think twice. See, maybe there is a syntax error that you missed, or maybe there is a line of code that will just simply fix it whole thing up rather than removing the whole big chunk. So just fix it very carefully. Okay. And last thing, always keep talking to your interviewer. I repeat, there is a marking schedule for communication also. So you will be not only marked according to your code, according to your understanding, but also to your communication. So keep talking to your interviewer, walk him through. Whenever you write a line of code, try to explain him why did you write this code. Try to explain the problem, and also try to explain how did you solve or how did you overcome this problem. Okay, so this concludes the problem solving flowchart. Okay, so the next topic is what to expect when you sit for an interview. Okay, this part will be presented by Leila. So I will hand over the session to Leila and she will continue from here.
Thank you, Buddha. That was great. So, what to expect? Of course, interviews are supposed to be difficult to test the candidate. Listen for guidance from the interviewer. It's important to listen and also not just listen, ask. You can ask. Don't just stay silent. The interviewer may take a more active or less active role in your problems. It depends on your problem, if it's difficult or if it's easy, and what if he want to test your personality. So this depends on this. So the level of interviewer participation depends on your performance. So some interviewer may help you if they find you struggle in some points, but you kind of understand and you kind of give good logic. So you can also ask, this will make them like, I wonder if I can do this, or if it's okay, they will guide you. And I hope you lift out a good interviewer. So optimizing and solving techniques. We talk about PUD. So we'll talk in depth now. So bottlenecks. A bottlenecks is the part of your algorithm that slows down the overall runtime. It may be a for loop, nested for loop, or repeated works. So let's see. An example, given an array of distinct integers values, count the number of pairs of integers that have different k. Let's assume the array 1, 7, 5, 9, 2, and 12, 3. And k is the difference. So 4 pairs with difference to 1 and 3. For example, 3 minus 1, the difference is 2. 5 minus 3, the difference is 2. 7 minus 5, the difference is 2. And 9 minus 7, also the difference is 2. Let's assume that we will, the bottlenecks here is to the repeated search for the other side. So we kind of go through from 1 and we check 7, 5, 9, 2, 12, 3 to find the right pairs. So this is very consuming, very time and space consuming. Second, unnecessary work. Example, print all positive integers. Solution to the equation a cube plus b cube equal to c cube plus d cube, where a and b and c and d are integers between 1 and 1000. So let's see the code. N equal to 1000 for a from 1 to n, also b from 1 to n, c from 1 to n, and d from 1 to n. If a cube plus b cube equal to c cube plus d cube, print. And this is, you can see for loop. So what we can do, we can do the last step, which is D, equal to power a cube plus b cube minus c cube. It doesn't matter how we found this step. It may require some mathematics, but we actually optimize this from O n power of 4 to O n power of cube. So yeah, find something to optimize. That means you can see here four for loops, and here we have three for loops. Duplicated work example. The same example, a cube plus b cube equal to c cube plus d cube, where a and b, c and d are integers between 1 and 1000. So here is the use of dictionary. I mean hash tables. We will study this in the next chapter, I guess. And yes, so here you can see that for C from 1 to n, from D from 1 to n, result C cube plus D cube. Append CD to the list at value map result. From A from 1 to n and B from 1 to n, result A cube plus B cube. This map.get result. This code will actually reduce how we here kind of have many for loops, and many, even if we optimize the last step here. Sorry, yes, here by using the hash table we kind of not start from the first element to the last element. We kind of use something called keys, not index, not go by index but by keys. Yes, it doesn't matter if you didn't understand this code now, you will understand it later. So handling incorrect answer. So if you are in an interview and you kind of give an incorrect answer, how to deal with it? So when interviewer evaluate how someone has performed in an interview, they don't think how many questions did you get right. So if you get one question or two questions wrong, it doesn't matter. It's only a rumors that you have to get all the question right. It's not a binary evaluation. So how optimal their final solution was. So you may actually get a wrong answer in maybe one question, and interviewer give you another question to test you. Maybe he find you confused about something, and you give optimal solution in the second one. So they won't care about the first one, which you get incorrect. How long it took them to get there? It's very important the time. How did you get for and how what did you use to shortcut these steps? How much help they needed and how clean was their code? It's very important cleaning to have a clean
Hard problem
code
with this
because
service. Sorry.
sorry.
Sorry, Leila.
Okay, no problem. Because you are at the end of the day, they are gonna hire you to work in a team. So it's important to have a clean code that they can come back to it and read it and maintain it. So be careful with that. Even if you wrote unclean code, maybe you just thinking and coding and then you clean it, they will consider it a clean. Okay, so your performance is evaluated in comparison to other candidates. So even if you are good at some point, or maybe you are lucky and the other can as good as you, I think I get lucky in some point on some interviews. So Many possible must questions are too difficult to expect, even a strong candidate to immediately put out the optimal algorithms. Yeah, not all candidates will get the optimal algorithm, but it's worth trying, and you may be lucky actually. So, when you have heard a question before, now this is uh, you might find it funny, but you're actually studying from different website, and you kind of have this question in the interview that's same as something you solved. So how to deal with it? Should you tell the interviewer that yeah, I know this question, or you solve it and you kind of get the credit? So it's actually better to admit that to interviewer that you know actually this question, and they will give you a big honesty point. I don't know if that's true or not, but maybe they test you something very easy, or it, I hope you give me some feedback after we finish about this slide. So, the perfect language for interviewers. Now, I don't know if all of you know Java or C++, but many of us have one favorite language. So, it doesn't matter which language, but what language you are really, really good at, use it. For example, myself, I love JavaScript, and I'm not good as I'm proficient يعني, but uh, I kind of know how to use it, and I kind of know how to debug with it and write algorithms and everything. So if your preferred language is actually Java or maybe Python, use whatever you want. So here you see examples here, Python and here Java. Uh, Python may be shorter than Java, but Java is like more descriptive, and you can actually uh, elaborate more when you explain to the interviewer. But it's up to you. Whatever you kind of understand better, use it. So, what good coding looks like? A good coding should be first correct and should be efficient for time and space. It should be simple. I mean, you saw a very complicated code in the maybe in the internet or in the Stack Overflow or something, and you say, "Oh, they are genius." It doesn't matter. Actually, keeping it simple is the genius. Readable, as we say before, you are be hiring to work in a team, so it should be readable, maintainable. So it should be maintainable in terms of if they can actually do something with it in the future and not rewrite it from the scratch. Use data structures generously. Yes, this is maybe you can actually solve the problem without using some data structures, but it's better to use a data structure because it's a bonus. Appropriate code reuse. They will give you a problem. If you solve it maybe in one code, they will actually consider it correct. But if you actually divide this into many functions and you can actually reuse these function, it will give you modular. I think modular means the same thing, but you kind of can reuse it, and you can combine it together. Flexible and robust. Flexible and robust, it means it can be you reused in the long term. And error checking, we can check it for error, and actually you can check this code and debug it. Okay. And finally, thank you so much for your valuable time and attendance from me and Buja and all the team. And this is the name of the book if you want to read it. And this is the author. Thank you so much.
Yeah, we actually finished on a very good timing. It's 10:03, and we are on a very good zone. And I just wanted to add one small thing is at the end of the day, don't give up. We all know that interview questions will be overwhelming, but that's the part of the interview is testing you out. Do you rise to a challenge, or do you shrink back in fear? It's important that you step up and eagerly meet a tricky problem head on. After all, remember that interviews are supposed to be hard. It shouldn't be a surprise when you get a really tough points or a really tough problem. And there are extra points to show excitement about solving hard problems. So just never give up is the thing. And even if you feel that you are not 100% into the topic, but try your level best at the end of the day. And that's it that I wanted to conclude. Lila, would you want to add on something for others too?
Uh, don't be hesitate to, even if you feel that you are not compared to other candidates, try, because you might be lucky actually.
True. True. And I think so. Whenever we think of interview, we always have this perception that maybe I will not do good. Maybe there are far better candidates. Yes, there are far better candidates. Java. There might be someone who is not comfortable in Java or say JavaScript or C++. So always own your zone, own what you understand. Try to not impress, but try to show yourself in your code or your explanation, because at the end of the day, no, it doesn't matter that you solved the problem in, suppose, say 30 minutes. You solved the code in 30 minutes, but you don't know how to speak, or you don't know how to communicate, how to explain to your interviewer. You will kind of lose marks on it. So be confident, be head on, and try to grasp it as soon as possible. That would be my last word. And so far, we finished it and we are on time. So, me and Leila, we will be here. If you have any questions, please write us in the chats, or you can open your mic and we will be glad to hear from you. And also, if anyone who is new to us, who just joined us, if you're willing to be a core team member in GDC, please feel free to join us. We are doing new sessions almost every day. Currently, we are working into a Python boot camp, which we are doing every day. So every day for an hour. It's a fun session. So I am a beginner in it, and most of us are in a beginner stage. So we are here to learn together. So feel free, and if you're willing to join the core team, do contact Abdurrahman. He will be guiding you through it, and it's a fun zone. Feel free to join us. That's it. If Abdurrahman, you want to add on something on it?
Um, we just finished the session, and I hope you liked it. Guys, please fill in the feedback form so we can deliver better content next time. And if you have any further questions, any further suggestions on what sessions should we do next, please write in the feedback form as well, or reach out to me on the WhatsApp group, or on private on WhatsApp. All right? Yeah. Thank you, Jaber.
Yeah, I even mentioned the book that helped us curating this session in general. It's the Cracking the Code interview by Gail Lackman. So you can look into it. I wrote the name in the chats if anyone is interested. I searched Sushant referring about it. So I just wrote it in there chats, so you can look into it. And if you have any questions, please, me and Lila, we will be here to answer them. Feel free to write it on the chats. Shant has a question. He says that in the end of the interview, when the interviewer asks if you have any question, what would be the best question to impress them? I see.
Yes.
I think so. It differs from person to person.
And imagine you are actually accepted and you will be working. So ask as if it's your first day. Ask what am I going to do? What the environment there, the team. ask if you as if you like beginning the job, your first day. This is
Correct.
the best
Even
answer.
Abdurrahman said something. He said like one good question is to ask what is your feedback on this interview. Correct. That would be a good question. According to me, I feel like if I've asked something, I would probably ask about the position that I'm kind of applying. Like maybe get little bit more detail about the position, how it works, how the office looks like in general, and what is overall working environment will be like. What are they kind of expecting from me? Maybe that could be a good starting point of questions. Oh wow, Javed just curated a whole list. Okay, let me read it out for others. So the question is, if hired, to whom do I report? Yes. Am I replacing someone? Why did that person leave? How many how many people are in the department? What are the training and educational opportunities? How is the job important to the company? And the next steps would be, what are the next steps in the hiring process? Yes, this could be a good question, that what are the next steps in the hiring process, I think. How many other candidates are you interviewing? I don't know if I will ask this, but yeah, people might ask it. When do you expect to make a decision? Will you bring candidates for another round of interview? If yes, then when? Yeah, that is also a good question. Yeah.
Perfect. Correct.
We already took a lot of time, so if you guys have something very important to carry on, so you can leave the session. Feel free to leave the session.